In physics, we have a lot of things that happen in regular fashion. These things we call, let me change my ink here. We call them things that happen in regular fashion, simple harmonic motion. Simple harmonic motion, SHM. Simple harmonic motion. This can be a whole bunch of different things that just happen at a regular rate. And when they do that, what we talk about two things. We can talk about the frequency at which the thing is happening, or we could talk about the period, which is how much time it takes for one of those events to happen. So as an example, we could have the planet Mercury. We could have the planet Mercury, and we could have the sun. It should make the sun way bigger than Mercury, but I don't know why I didn't. But sorry, that's the way I did it. Okay, so Mercury can go around the sun 4 times in one Earth year. In one Earth year, the Mercury will go around the sun 4 times in one Earth year. So what we do there is we call that's called the frequency. So the frequency is 4, we'll call it revolutions, 4 revolutions per year. Okay, normally we want our time to be in seconds, but in this case the frequency is 4 times per year, 4 revolutions per year. So what a lot of times we want to figure out is what would be the period, and the period is capital T, and it's given, it's a time, right? It's a time. And it's the time that it takes one event to happen. So how much time does it take for Mercury to go around the sun just once, for one event to go? Well, you can probably just figure that out, but the easiest way to do that is just take 1 over the frequency. So if it takes Mercury if Mercury goes around the sun 4 times in 1 year, then the amount of time it takes it to go around once would be 1/4 of a year. So all you do is you take 1 over the frequency, so that'd be 1 over 4, okay? Or you basically flip it. And so you had 4 revolutions per year, so now you have 4 revolutions per year. So now you have like 1 year per 4 revolutions, or you have 1/4 of a year. 1/4 of a year is what the period would be. So if you know the frequency, which is how often something happens, how many times per time it happens, then the period is just the inverse of that, or you can flip it back over either way. Okay, normally the frequency is in things per second, is what it should be in, things per second. So frequency is, the units would be like, 1 over S, things per second. And a thing per second we actually call hertz. We call hertz. So that's how often something happens in a second. And to find the period, you take 1 over the frequency, and then you would have the units for period, of course, is seconds. Okay, so that brings us to this problem. What do we have here? We have 120 meteorites. So this is kind of unusual, but these 120 meteorites we're assuming are falling at regular intervals over a time duration of 4 minutes. 4 minutes. So that's meteorites per minute. That would be a frequency, right? How often something's happening. Now, we don't want that to be in 4 minutes. We want that to be in seconds. So 4 minutes, there's 60 seconds. 60 seconds in a minute. So 60 times 4 is 240. So it's 120 meteorites fall in 240 seconds. That is a frequency. So that frequency would be 120 over 240 is basically half a second, or half a meteorite per second. That's your frequency, okay? And a meteorite isn't, it's not really a unit, so it's just half a hertz. So the frequency is 0.5 hertz. So what is what's the time? What is the period of time? Well, you're gonna flip that, right? You're gonna flip that. So what do you get if you flip 1/2? You get a period of 2 seconds. So every 2 seconds, a meteorite is going to fall. Now, the tricky one with this one is how many sig figs should you have? And 120 is a counting number, right? So we don't use that at all. This is a measurement, time, and there's 3 sig figs. So you still need to have 3 sig figs. So your period, a meteorite's going to fall every 2.00 seconds. Hopefully that makes sense. You're going to need to know a lot about period and frequency. They are inverses of each other.